my name is Prabsimir Kaur, and in this video I am demonstrating my 5.3 HD task. The objective of this task is to show how we can remotely call a function in the Arduino 33 IoT from the web interface. We are simulating a traffic junction where authorities can control traffic lights without being physically present. For this demonstration, we use 3 LEDs to represent traffic lights, a web interface built with HTML, and a Firebase as a cloud bridge. Let's have a look at the hardware first. Here we have the Arduino Nano 33 IoT, which acts as the central microcontroller, which has a built-in Wi-Fi support. It communicates with the Firebase to fetch control commands. Then we have used LEDs that are red, yellow and green. These represent the actual traffic lights and protect, and at an intersection the resistors are used to limit the current flowing into LEDs and protect them. We have set up the system on the breadboard using the jumper wires. Now let me explain you the software. We have used a web application, made a web application using the simple HTML and JavaScript that is interconnected to the Firebase. The RHTML provides button red, yellow and green. Along with that we have an on, all, off button, which basically controls the turning off of all LEDs. The LEDs, when the user press the button, we can control the traffic lights with that. Then we have written an Arduino program which basically connects to the Wi-Fi, communicates with the Firebase using the Firebase Arduino Wi-Fi Nina library, and switches the LEDs on or off based on the commands stored in the Firebase. The reason we use Firebase is because it provides the real-time synchronization, global accessibility and the serverless cloud hosting. And we chose the Firebase Arduino Wi-Fi Nina library because it's specifically optimized for the Nano 33 IoT Wi-Fi module, ensuring smooth and stable operation. We have then created a Firebase data FBDO object. This object acts as a communication channel letting us send and receive data between the Arduino and the Firebase cloud. We have used a setup function. Firstly, we start the serial monitor for debugging purposes. Then we configure the LEDs as outputs. We connect the device to the Wi-Fi. The code awaits until the connection is successful. Then we have finally called the firebase.begin to connect the Arduino to the Firebase. In the loop function, the program continuously checks the Firebase database for updates. It looks for 3 values, that is traffic light /red, traffic light /green and traffic light /yellow. If the database has values, they are fetched and stored as integers, either 0 or 1, where 0 represents the LED is off and 1 represents like the LED is on. These values are then written to the corresponding LED pins using digital write. This loop runs every 200 milliseconds, so the Arduino is always in sync with the latest commands by the Firebase. Now let's see how the system works. You can see the demo of the working system. As you can see here, the red LED, when we press the red button, the red LED toggles. When we are clicking the yellow button, the yellow LEDs toggles on, and when we use the green button, the green LEDs toggle on. And when we are pressing the on/off button, all of the LEDs are off. This demonstrates real-time remote control. The system can simulate a rural traffic junction or remote device control. If we talk about how this system can be used in real life, this system is applicable in remote controlled traffic light management, street lighting, irrigation systems and home automation. If we talk about the potential improvements, we can use cloud APIs for faster integration. We can also implement MQTT for low latency communication. We can also add authentication and encryption for security. In conclusion, the project highlights cloud device interaction, modular design, and the real world applicability. Thank you.